Alright, so today we're going to do an example of the implicit function theorem in multivariables. So let f be a C1 function, so it has continuous partials. Suppose that exists, and suppose we have point x0, y0, z0, such that f that is c, and the partial derivative with respect to z is non-zero. Okay. Prove that there exists an open neighborhood u of x0, y0, and r squared, and a C1 function g from u to r such that g of x0, y0 is c0, and f of x, y, and g of x, y equals c for all x, y in this open neighborhood. And then finally, using chain rule, let's derive the formulas for dg dx and dg dy. All right, so this we can see is going to follow directly from just applying the implicit function theorem. So this all just follows directly from applying the implicit function theorem. And basically what we can do is we can define a new function h such that h of x, y, z is equal to f of x, y, z minus c. And now notice that our assumptions are satisfied. So our assumptions are satisfied since h of x0, y0, z0 is equal to f of x0, y0, z0 minus c. Notice this is equal to 0. And also df dz of x0, y0, z0 is non-zero. In other words, df dz is going to be invertible, and we want that to be true in order to find a unique function g such that g of x0, y0 equals z0, and also g of xy equals z for all xy in this open neighborhood. All right, and that then by the implicit function theorem, we see that there's this unique function g in like a local neighborhood of x0, y0 such that g of x0, y0 equals z0, and h of x0, or I should say x, y, z equal to 0 for all x, y near x0, y0. And then finally, this is where the chain rule is going to come in. We have that dg dz, this is what we're solving for, at x0, y0, z0 is equal to dg df, sorry dh dz, negative of that, inverted, times dh, and then these are the variables that we're solving z in terms of. So it's going to be dh dx and dh dy. All right, so now that we know this, we can use the chain rule. All right, so notice that when we take dh dz, that's just going to be equivalent to df dz, and that's because this constant will go away, and same with dh dx and dh dy. So this actually just turns out to be, and also notice that this will just be a scalar, right? Because it's a 1-by-1 matrix. So that's just going to equal to negative 1 over df dz times df dx df dy. All right, so now we can see easily that g dx is going to equal, and this, I'll just put it here. So then that's equal to df dx negative df dx over df dz, negative df dy over df dz. So dg dx is this, and dg dy is that. So dg dx is equal to negative df dx over df dz, and dg dy is negative df dy over df dz. And we're done.